Hello everyone, welcome back to Python programming tutorial. So for today's session, we're diving into world of Python modules. Specifically four powerful ones. I'm talking about the NumPy and then pandas and then SciPy. And the last one, it's Django. All right, so these modules extend Python's functionality in incredible ways, which help you to handle numerical computations, data analysis, scientific computing, and web development. So by the end of this video, you'll have a foundational understanding of each module and how to get started with them. Okay? All right, let's begin. Before we explore these specific modules, let's quickly understand what Python modules are. So a module is essentially a file containing a Python code. It contains functions, classes, or variables. Okay, I need to write it down here. Okay, so modules, basically, it's essential, essentially a file which is containing Python code, okay, which includes functions and then classes and then variables, okay, that you can import and use, okay, that you can import and use in your programs, okay. So Python standards library comes with many built-in modules like math, okay, and us. But there's also a vast ecosystem of third-party modules available via the Python package index. It's PyP. We call it Python. Oops. Sorry. Python package index. Okay, it stands for Python package index. So the modules we're covering today, it's only these four. Okay, it's only these four. Oops. Go to do like this. Okay. Uh-huh. Yeah. So these four. Yeah. NumPy, Pandas, Shy is big for science. SciPy and Django. It's uh these four modules are some of the most widely used in their respective field. Okay. To follow along, we'll be using Google Colab. Okay. It's a cloud-based platform which allows you to run Python code. Okay. Since we are using Google Colab, we need to, oh, sorry. Since we are using Google Colab, we don't need to install those libraries, okay, using PIP. If you are using a local machines that you need to do installations, the installations you need to start with PIP. Okay, you need to install these libraries. Yeah, for example, okay, just if you are running if you are running in your local machines, let's say you are running in your laptop, then to have these four um, modules, you need to install it. Yeah, by typing pip. Oh, sorry. Start with the this text. I don't know how to say it. Pip install NumPy, and then again pip install. Oh, you got me right. Pip install pandas, pip install SciPy, and pip install Jingo. Okay, let's start with NumPy, the first module. All right. So NumPy, it's short for, okay, I'll just, because I'm using Google Colab, so I don't need to do this. Okay, later I will show you. But before that, I would like to tell you some important thing about NumPy. Okay, let's start with NumPy first. So NumPy, it's short for numerical Python. It's a powerful library for numerical computations. It's introduced the AND array. It's a multi-dimensional array objects that is much faster and much more efficient than Python's built-in list for numerical operations. Okay, so this is NumPy numerical Python. Let's try coding. Okay, if you are using Google Colab, you don't need those pip blah 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 blah. Okay, you can just import NumPy as, yes, I'm going to type in this one, S and P. Okay, and then I'm going to, okay, let me tell you something. If you want to make some notes inside the code, you can just use this crash. Yeah. Okay. Creating 1D, oops, 1D array. So it's array equals to NP array. Okay. 1, 2, 3, 4, 5. All right. That's creating an array. The next one, I'm going to performing basic operations. So I'm going to do print an array here. So it's ARR. I'm calling this variable. Next up, print functions again. I'm going to do, yes, the sum function. So it's ARR dot sum. Yeah, right. Mm, very good. And then print. Okay, so this is a need function. If you are familiar with statistic kind of things, you know one of this function, it's mean. So you use this mean to know the middle value of a data. Okay, so it's mean array mean. All right. Mhm. And the next one, I'm going to create a 2D array. Okay. Matrix equals to np dot array one with two and then three with four. Yep. Okay. Then I'm going to print the 2D array. Going to backslash n, comma, matrix. I'm calling this variables matrix. Then next up, I'm going to do a transpose backslash n. Let me tell you, let me explain later, okay? And matrix dot t, yes, dot t. Okay. Okay, I will run it and explain one by one. Okay, so the NumPy is especially useful for mathematical computations, linear algebra, and working with large data sets. Its speed and efficiency come from its implementation in C language, which making it a cornerstone for data science and machine learning. All right, so when we are creating an array, there are some types, yeah. 1D array, it's only one, so it's a one list. You have 1, 2, 3, 4, 5, it's a one list, so it's 1D. When it's 2D, then it's a two lists. It's 1, 2, and 3, 4. So that's why we have a 2D array and 1D array. One dimension array, it means one list. Meanwhile, 2D array, it's two lists. Yeah, okay. And then let's come to the results over here. Okay, let's just okay. Let's go over here. So when performing basic operations, we print array first. Okay. So I want to print array, and here's the result arrays in 1, 2, 3, 4, 5. It's one list, okay, in one brackets, yeah, in a one brackets, and then sum. So the array is summed, okay, 1 plus 2, 1 plus 3 plus 4 plus 5, it's equal to 15. Okay, and then the array mid of the array is the middle value of the array. Here we can see that the middle value is 3. Okay, so the mean is 3. Come to the next one. When we create a 2D array, in this case, we have two lists. Yeah, okay, 1, 2, and 3, 4. So it's two lists. And then it's print, so it's just showing uh the 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 array, yeah, it's 1, 2, and 3, 4, and then transpose. So transpose is like changing a value, yeah. First it's supposed to be 1 and 2, and then 3 and 4. When we transposed it, it changed the value 1, 3, and 2 and 4. Okay, 1, 3, and 2, 4. Okay, that was the NumPy modules. Now let's talk about pandas. Okay, pandas. Let's talk about pandas. Okay, so pandas is a library which is designed for data manipulations and analysis. Okay, pandas is for data manipulation and analysis. Okay. So pandas introduce two primary data structures. Okay, the two, sorry. Two primary data structure. First one is the series. Yeah, it's the ID. And the data frame. Yeah, it's to the hmm? We always wrong. Okay, 1D and 2D. Let's move on to the examples. Okay. Import pandas as BD. Okay. And then I'm going to creating a data frame. So first of all, I would like to create a data frame. So it's a data equals to, okay, bracket, start with bracket, sorry, the curly bracket, and the name, let's see, Alice, okay, and then maybe Bob, and then Charlie. Next, H, yeah, H. Actually, you can go further to the right, but I don't like it. It's not neat. It's not, it's too complicated. It's too bulky. So that's why I put enter and move it to the downside. Okay. We have 25. Yeah, 30 is okay. And then 35. Okay, next again. Let's say score. Yeah, score. Mm, It's the grade. Yeah. Example is the exam grade. Okay. 65 and 90 and 95. Okay, and then DF. Yeah, so DF is the data frame. Okay, PD stands for pandas. PD dot data frame. I'm calling this data. Okay, and then print the data frame backslash n comma df. I'm calling this variables df. Next up, I would like to do some basic operations. Okay. So I'm going to do a print function. Let's see. It's n sorry, backslash an average of age. Okay. And oh, df. I'm taking the data from df, and then I'm going to take the age to be average, and then mean is for the average. Okay. Um then a print, another print, backslash n filter. Yeah, filtered data frame, backslash n, and then I'm going to take the score one. Yeah, the score one. df score greater than 90. All right, moment of truth. Let's run this code. Okay. So here is the result. Okay, so data frame here is showing the data. Okay, showing the data, all the data. Yeah. Alice, Bob, Charlie, with age, each age and score. And then I want to see the average. Yeah, the average of the score. Oh, sorry, the average of the age. Okay, so the average of the age is 30. Okay, 25 plus 30 plus 35. So the average is 30. The next one is the filtered data frame. Filtered data frame is, it means that it's only showing the data with some condition. Okay, here the condition is score more than 90 or greater than 90. So who's the greater than 90? It's Charlie. It's Charlie. So uh, here the result show Charlie. Age 35 with score 95. All right. Now let's move on to the next modules. It's called SciPy, Science Python. Okay. So this modules, this library builds on NumPy and provides what is called additional functionality for scientific and technical computing. It includes modules for optimization, integration, interpolation, signal processing, and many more. Oh, sorry, I forgot to write it down. Okay. So basically, SciPy, it's additional functionality for scientific and technical computing, which includes optimization and then integration, interpolation, signal processing, and more. Okay, that's SciPy. Okay, let's move to the code. From SciPy dot optimize import minimize. Okay. First, I'm going to define a function to minimize. Minimize, okay? So let's start by def. I'm going to explain to you, don't worry, okay? Okay. Return to plus 5 plus 4. Okay, let's run this code. Okay, so I was defining a functions to minimize. Okay, so I want to add some more to minimize the function. Mhm. Result equals to, yeah, it's minimize the objective, yeah. Mm-hmm. Zero. And then print the optimal value means that I'm calling the result of x. Okay, let's run this code. All right, so the optimal value is this. Okay, this is how you define a function and then minimize the function. All right,